Good morning, dear students. Yesterday we have covered the general introduction of D block elements, and with the general introduction we have also completed some important properties exhibited by D block metals or D block elements. Now today we will start with the two most important compounds of D block series. First important compound is of manganese and second important compound is of chromium. Compound first of manganese is KMnO4 and compound second of chromium is K2Cl2O7. KMnO4 is called potassium permanganate and K2Cl2O7 is called potassium dichromate. Now, why these two compounds are very important? They are important because both the compounds act as a strong oxidizing agent. Reason why they act as a strong oxidizing agent is very simple. If you see the electronic configuration of manganese, its outermost electronic configuration can be written as 3d5-4s2. In 4s we are having 2 electrons and in 3d we are having 5 electrons. So in total there are 7 electrons which can be involved in bond formation. Ultimate shell electron and penultimate shell electron both can be involved in bond formation or compound formation. Then second, we are having chromium having outermost electronic configuration as 3d5-4s1. In 4s we are having 1 electron and in 3d we are having 5 electrons. So in total there are 6 electrons which can be involved in bond formation. So here in KMnO4 the oxidation state of Mn is +7. While for chromium the oxidation state is +6. It means all the 7 electrons from manganese are transferred towards the oxygen atom. So there are no more electrons left with the manganese. So what will happen? Manganese will have a strong electron attracting tendency, because there are no more electrons left with the manganese. So now manganese cannot lose electron. So if it cannot lose electron, then in that case it can attract the electrons. Because it is attracting the electrons, KMnO4 act as a strong oxidizing agent. Similarly, chromium, its oxidation state is +6. All the 6 electrons are transferred away from the chromium. No more electrons are left with the chromium. So now chromium will be having a strong electron attracting tendency. And that's why it acts as a strong oxidizing agent. Now, let us see the reaction of potassium permanganate first. In acidic medium, MnO4 minus ion that we have obtained from KMnO4. K plus is not important here. It does not involve any change. It does not undergo any change. That's why it is removed from here. It's not written here. It's not taking part in redox reaction. So K plus is removed. So what is left? Left part is MnO4 minus ion, which is called permanganate ion. So MnO4 minus ion in acidic medium gets converted to Mn+2. If we balance the reaction according to ion electron method, then we will get MnO4 minus plus 8H plus 5 electrons gives you Mn+2 plus 4H2O. MnO4 minus is gaining 5 electrons here. And that's why oxidation state of Mn from +7 gets converted to +2 here, because Mn has gained 5 electrons. Because it is gaining electron, so it is showing reduction. And the species which shows reduction can act as oxidizing agent. So this is the reduction reaction of KMnO4, where it is gaining 5 electrons, and that's why it acts as oxidizing agent. Now, when it is used with other substance like Fe+2, so in acidic medium, KMnO4 oxidizes Fe+2 ion, which is called ferrous ion, to Fe+3 ion, which is called ferric ion. Similarly, C2O4-2 ion, which is called oxalate ion. Oxalate ion gets converted to CO2, that is carbon dioxide. In oxalate ion, the oxidation state of carbon is +3, and in carbon dioxide, the OS of carbon is +4. So +3 oxidation state of carbon gets converted to +4. Increase in oxidation state is there for carbon atom. So it's called oxidation for oxalate or carbon. So C2O4-2 ion gets converted to CO2, that is called carbon dioxide. Similarly, NO2- ion, which is called nitrite ion. In nitrite ion, the oxidation state for nitrogen is +3. In presence of KMnO4, it gets converted to NO3-. It shows oxidation. It forms nitrate ion, where oxidation state of nitrogen is +5. Increase in oxidation state for nitrogen is there. So conversion of NO2- to NO3- is oxidation, and it takes place in presence of KMnO4. Similarly, SO3- ion, which is called sulfite ion. In sulfite ion, oxidation state of sulfur is +4. It gets converted to SO4-2, which is called sulfate, and in sulfate, oxidation state of sulfur is +6. So +4 state of sulfur gets converted to +6 state. Increase in oxidation state of sulfur is there. So whenever increase in oxidation state is there, it is called oxidation. So KMnO4 oxidizes sulfide ion to sulfate ion, where sulfur exhibit change of oxidation state from +4 to +6. +6 is highest for sulfur. Similarly, next case, H2S, which is called hydrogen sulfide. In H2S, OS of sulfur is -2. H2S gets converted to free sulfur. Free means oxidation state will be 0. -2 state gets converted to 0. -2 to 0. Increase is there. So again, this is oxidation. Conversion of H2S to S is oxidation, and it takes place in presence of KMnO4. Similarly, S-2 ion or sulfide ion gets converted to free sulfur, and at last I-, which is called iodide ion, gets converted to I2, which is called free iodine. In I-, OS of I is -1, and in free iodine, OS of iodine is 0. So -1 state gets converted to 0 again. So it is oxidation, and it takes place in presence of KMnO4, which works as a strong oxidizing agent. Now, if the medium is changed, instead of acidic medium, now we are using neutral medium or slightly alkaline medium, then progress of reaction will change. In acidic medium, MnO4- gets converted to Mn+2. +7 state gets converted to +2 state, but in a neutral medium or slightly alkaline medium, MnO4- gets converted to MnO2, manganese dioxide, which is called pyrolusite. Here, OS for Mn is +7, and here OS for Mn is +4. Here it was +7 to +2, and here it is +7 to +4. So here reaction can be written as MnO4- plus 2 H2O plus 3 electrons gives you MnO2 plus 4 OH-. If we compare the reduction of KMnO4 in acidic medium and slightly alkaline medium, then by observing the electron gaining tendency, we can very easily tell that KMnO4 is a better oxidizing agent in acidic medium if it is compared with neutral medium or slightly alkaline medium, because in acidic medium it is gaining 5 electrons, while in neutral medium or slightly alkaline medium it is gaining only 3 electrons. Now what happens in slightly alkaline medium or neutral medium? KMnO4 oxidizes H2O3 minus 2 ion, which is called thiosulfate ion, to sulfate ion, and I minus ion to IO3 minus ion, which is called iodate ion. Please see the difference here. In acidic medium, I minus ion gets converted to I2, but here in neutral medium, I minus ion, the same iodide ion gets converted to IO3 minus ion, which is called iodate ion. That's all for today. Thank you and have a nice day.